In this demo, I'm going to be talking about the global wind belts. I'm just going to draw on the board a large globe so you can visualize it. We know that the globe, not perfect circle in this case, is divided into different lines of latitude. So we'll put the equator in at 0 degrees latitude, 30 degrees north latitude, 60 degrees north latitude, and then I'm just going to draw a little dot at the top for the North Pole, which is at 90 degrees north latitude. And then we have the same bands in the southern hemisphere as well. So these are just 30 degrees south, 60 degrees south, and then 90 degrees south. Now, these different bands actually help us identify where the different global wind belts are. Between about 25 or 30 degrees north latitude and the equator, we have the northeast trades, okay, and they're coming in from the northeast. All winds are named from the direction that they're coming from, and they do actually rotate around because Coriolis is deflecting them as they move. So we can draw these onto the board. Okay, we also have trade winds in the southern hemisphere that are coming up towards the equator. So we have some convergence that's happening right at the equator. We know that when winds start to converge, this is one of our airlifting processes. So I'm going to draw vertical circulation over on the side. So we actually have air rising at this point. So this is associated with a low pressure center right here because we have rising air. Okay. If we start to look at what's happening between 30 degrees latitude and 60 degrees latitude, we're going to have our westerlies. These are moving from the west, and they're going up towards 60 degrees. And down at the bottom, they're doing the same. Okay. And then before I go on and start talking about some of the vertical circulation, I'm going to draw the last belt of winds. These are coming down from the poles. They're called polar easterlies because they're coming in from the east and the poles. And then again, we're going to draw these as well. Okay. Whenever we have air that's moving away from the same location, it has to be replaced by air from aloft because we can't just have a void. So on the vertical circulation, we have air that's descending, so this is a high. Okay. Up here, it's converging again, so it's going to be rising. Okay. At the poles, if we could imagine looking down on top of this, all of these winds are moving out of the pole, so air is constantly being replaced by air from aloft at the top. Okay. And then over on the side, we have this divergence. Air is replaced from above. Convergence, it rises, and then it's moving away. It's going to be descending again. Okay, so that's just kind of giving us an idea for what's happening at those locations. We can actually connect it in. These winds are also moving on this belt, and they go from areas of high to low pressure. Okay, areas of high to low pressure. And when they get aloft, they actually do diverge as well. So these are going in opposite directions. Here, high to low pressure, and then air flows out and away, and then back. So we're actually looking at some vertical circulation, and these are going to be called our Hadley cells, and they help us understand what's really happening, kind of in that vertical sense, and then it would just continue as we go around the globe. Okay. So some interesting, the polar areas, because we have descending air, it's going to be very dry. Just remember that because of the adiabatic process, as air starts to descend, we're taking the same number of molecules, we're forcing them into a smaller area. Pressure is increasing, so the air molecules bounce off of each other and they actually start to heat up. Warm air can hold more moisture, so the humidity goes down. So we get really dry zones wherever we have this descending air. So right about 30 degrees latitude in the north and south hemisphere and at the poles. Okay, so that's some help on global wind belts, some vertical circulation, and a little bit more information about high and low pressure centers.